Dear students, in this video we are going to discuss mass spectroscopy. Mass spectroscopy is divided into two parts. In the first part, it consists of what is mass spectroscopy, basic principle, mass spectrometer, various method of ionization, molecular ion peak and base peak. And in the second part of this video, it will be discussed the characteristics molecular ion of different molecule. So let's start with what is mass spectroscopy. So mass spectroscopy is little bit different with other spectroscopic method because it is not related to the absorption of electromagnetic radiation energies. Rather, the molecule is bombarded with high energetic electron beam and it is fragmented, and the mass spectroscopy is used to determine the molecular mass of the compound and its elemental composition. So in this technique, the molecule is ionized and it broken up to fragments, that is positive ion, and each kind of ion has a particular m by z ratio. Normally z is equal to charge is equal to 1 and m is equal to mass. For example, in this molecule, it is bombarded with high energetic electron beam and it will lose electron and it will give this ion. That ion is molecular ion which has the mass m by E equal to 72. Further, it will fragment it to different types of ions of different types of masses, like C4H9 plus, that is 57, C3H5 plus of mass is 41, C2H5 plus of mass 29, C2H3 plus of 27. So the molecule has different molecular masses and this molecular mass of the compound will be determined in a mass spectroscopy. So the theory includes the mass spectrometer perform three types of works. First is it vaporizes the compound of varying volatility. It is in mass spectrometer the molecule is vaporized. Second is the vaporized molecule is ionized. And third is the ions are separated according to the m by z ratio and record. So in mass spectroscopy, the molecule is bombarded with high energy electrons. It will form a radical ion. After losing one electron, it will form a radical ion, and this radical ion is highly energetic and it will fragment to datar ions. So each datar ions, including that molecular ion, have different m by z ratio, and in x-axis the m by z ratio is plotted and in y-axis the relative intensity will be plotted, and we will get some peaks like this. Here the parent ion, that radical ion which is formed after bombardment with the electron beam, it is molecular ion, and the peak extreme right hand side, it will be molecular ion peak, and the peak with highest intensity, it is called base peak, and the intensity will be taken as 100%, and other peaks will be considered relative to that base peak. Now when you consider the relative intensity will be dependent on the relative abundance of the ions. So more easily it will be available, then more intense will be the peak. So relative intensity is directly proportional to the abundance of the ions. Sometimes along with the molecular ion peak and base peak, other peaks are also obtained with non-integer value. Non-integer value means, suppose this is 40, this is 60, some within this 40 and 60, some 40.2, 60.5, some peaks with non-integer values are obtained with very broad peaks. They are very broad. These peaks are called metastable ion peak. These ions are called metastable ions. This is a typical mass spectrometer which consists of reservoir, ionization chamber, electric and magnetic field, collector and detector, amplifier and recorder. So in reservoir, the molecule is vaporized and it is passed into the ionization chamber. Different techniques are there to ionize the sample, and the ionized ions are passed through electric and magnetic field, and it follows a circular path, and it is then collected and detected, and it is then separated. The signal coming from the detector is converted to the digital form, and this digitalized data are stored in computer memory, which are further obtained as peak. So in ionization chamber, different methods are there to ionize the molecule. First is electron ionization or electron impact, second is chemical ionization, and third is fast atom bombardment. In electron ionization, the molecule is directly ionized with an electron beam of energy of 1.1 to 10 to the minus 17 joule, high energetic electron beam. The molecule is collided, so it will form a radical ion. For example, alkene, it is bombarded with electron beam, it will form a radical ion. It is alcohol, it is radical ion. Carbonyl compound, radical ion. Aromatic benzene, it is radical ion. So normally non-bonding electrons are very easy to ionize compared to sigma bond or pi bond. So order of ejection of electron is non-bonding is greater than pi, then aromatic, then sigma. So this method has some disadvantages. What are they? So this since it is very fast, since it is high energetic method, so the molecular ion obtained is highly unstable. We will not get the molecular ion peak. Similarly, we cannot determine the molecular weight, exact molecular weight of the compound. The spectra is very much complicated. So large numbers of fragments are obtained. These are the disadvantages. In the second method, it is chemical ionization, where a reagent gas such as methane, ammonia is passed into the ionizing chamber. So in the ionizing chamber, methane, ammonia, these are the gas passed, and these methane, ammonia gas are collide with the electron beam of the ionizing chamber, and it will form some reagent ions. Methane, it is collided with electron beam, it will form reagent ions, CH3 or CH5 plus, CH3 plus, CH5 plus. So these are reagent ions. Then these reagent ions will collide with the sample, and it will protonate the sample to form MH plus, and we will get M plus 1 peak, because plus 1 mass is more in the molecule due to this H plus. So this is not a direct ionization technique. Initially, the reagent gas is ionized to form some reagent ions. These reagent ions will collide with the sample. This is a soft ionization technique. The third method of ionization is fast atom bombardment. In this method, the sample is bombarded with high intensity xenon atom, and this method is used for large molecule and involatile molecules, and here normally unstable compounds can be studied. So this is a molecule, normally this is ionic compound, and it is bombarded with high intensity xenon atom, and we will get the fragments. Next, there is a rule, that is nitrogen rule for mass spectrum. That nitrogen rule states that if M by E of molecular ion or any data ion is even, the number of nitrogen present in the molecule is even or zero. And if the molecular ion or data ion peak is odd, the number of nitrogen present in the molecule will be odd. That means, suppose this is a molecule, after losing on an electron, the radical anion will have M by Z is equal to 45, which is an odd number. So From here we can conclude that the molecule has odd number of nitrogen, that is 1. Similarly, in this molecule, the molecular ion peak has m by E equal to 50, that is even. Number of nitrogen present is also even, that is 2. This is the nitrogen rule. Of abundance. So already we know that the intensity of the peak is directly proportional to the abundance of the ion. If a molecule has n carbon atoms, then it will show m plus peak due to its 12C carbon, and it will show m plus 1 peak also due to its isotope of 12C, that is 13C. And the intensity of this m and m plus and m plus 1 peak will be dependent on the natural abundance of the isotopes. Suppose there is a table of isotope and their natural abundance in percentage. This is 1H, abundance is 99.98, 2H 0.015, 12C 98.9, 13C 1.1, 14N 99.64, 15N 0.36, 16O, 17O, 18O 99.8, 0.04, 0.2, 35Cl 75.8, 37Cl 24.2. So if a molecule has carbon atom, then it will show m plus 1 and m plus peak with intensity of the ratio 1:1:98:9. Similarly, if a molecule has a chlorine atom, the intensity will be for m and m plus 2 peak. M plus 2 means 35 plus 2, 37. M and m plus 2 peaks with relative intensity 3:1, 75.24.2, 75:25 equal to 3:1. So m and m plus 2 peak will be appeared in the intensity ratio 3:1. Similarly, for bromine, the abundance is for 79 Br is 50.5 and its isotope 81 Br has 49.5, almost equal, 50-50. So if a molecule has a bromine atom, then it will appear as m and m plus 2 with 1:1 ratio. So if a molecule has 2 chlorine atom or 2 bromine atom, then how we will decide that what is the intensity of the peaks? So it will be expressed in a binomial expression, that is a plus b to the power n, where n is the number of atoms present and a and b are the relative abundance of the isotopes. Suppose for chlorine it will be a equal to 3, b equal to 1. So it will be a plus b to the power n. Suppose for a ion containing 2 chlorine atom, it will be a plus b whole square, a square plus twice a b plus b square, 3 square plus 2 into 3 into 1. We have to put the values of a and b here, and we are getting the ratio 9:6:1. That means the ratio for m plus 2 and m plus 4 is 9:6:1. Similarly, if the a molecule has 3 chlorine atom, then a plus b to the power q, a cube plus 3a square, b plus 3ab square plus b cube, then a value is 3, b value is 1, 27:27:9:1. So m plus 2 and m plus 4 and m plus 6 ratio will be 27:27:9:1. Similarly, for bromine atom also we can calculate, where a will be 1, b will be 1. That's all for this video. In the second part of this video, we will decide the numbers of fragmentations for different functional groups. Thank you.